Last time we ended on this problem, we said that V is the vector space R2 with the following bases, B1 being 1, 1, negative 1, 1, and B2 is 3, 2, 4, 3. We wanted to find the change of basis matrix from B1 to B2. We said that we're going to use this notation for the change of basis matrix. We're going to put an I with these two brackets here, and we're going to say where we start from, B1 is on the right, and we go to B2 on the left. And we found this matrix, this 2 by 2 matrix. And how we found it was we wrote each one of these basis vectors in B1 in terms of these basis vectors. So this one, this column, is V1 in terms of B2, and this column is V2 in terms of B2. Once we found this change of basis matrix, then we were asked to find the change of basis matrix from B2 to B1. So again, we put B2 on the outside because that's the one we're starting with, and we're going to B1, which we put on the left. And we found this matrix by doing something similar to what we have here. Here we put, which I'm going to call this element W1 and this one W2. This column is W1 in terms of B1, and this column is W2 in terms of B1. So we take each one of the vectors in B2 and write it in terms of B1. We also said that we could just take the inverse of this matrix that we found, and that will give us the matrix we're looking for, this change of basis matrix. Now, if our vector space had n elements in its basis, and we had two bases, both with n elements, then the change of basis matrix is going to be n by n. So if we wanted I from B1 to B2, we would take each one of the n vectors in B1 and write them in terms of each one of the n vectors in B2. So we'd have n columns and n rows. Now we're going to continue with this problem. Here I'm going to give you a vector v in R2 that's negative 4, 8. And I want to know what is v in terms of B1 and what is v in terms of B2. So let's start with figuring out what v is in terms of B1. So to figure out this coefficient matrix, we need to find the C1 and the C2 such that 1, 1 times C1 and negative 1, 1 times C2 gives us this matrix. And this matrix here is going to be equal to C1, C2. So whatever we find for C1 and C2. So let's do this. How we're going to find the C1 and the C2 is we're going to make an augmented matrix and put that augmented matrix in reduced row echelon form. This one is easy. All we have to do is subtract row 1 from row 2. You'll see that we get, we did this also before in the last video, putting this matrix in reduced row echelon form. So 2, 12, 1, negative 1, 4. Then divide by 2. We get 1, negative 1, 4, 0, 1, 6. And then we're going to add row 2 to row 1. And we'll get 1, 0, 10, 0, 1, 6. So C1 and C2 are 10 and 6. So let's put that in. So 10, and 6. Let's double check. 10 minus 6 is 4. Oh, did I make a mistake? Let's see. I might have. So this was, let's just double check everything. So we wanted a negative 4, right? I see what I did. I forgot to keep this as a negative. That's okay. And that's why I want to double check, because it's really easy to make a mistake. So let me just go back. So I think this is still correct. Here we have a negative 4, so we didn't do anything to this one. And then I need to erase this 10. And then we added this, so we got a 2 here. Okay, so C1 is actually 2. All right, now let's check it. 2 plus negative 6 is negative 4. That's correct. And 2 plus 6 is 8. So this matrix, that's C1, C2, is actually 2, 6. So we found this piece, and I'm going to, I think what I'm going to do is I'm going to erase this so I have some room. I'm going to copy, or actually just move this piece up. And now I'm going to show you how to find the second piece. So we want V, B2, so the coefficient matrix of V in terms of the basis B2. Now we can do the same thing we did before, which was we tried to write negative 4, 8 in terms of the basis. Let's do that, but I want to show you how we can also use that change of basis matrix we found earlier. So we want a C1 and a C2 for B2, which we said B2, the basis was 3, 2, 4, 3. So 3, 2, 4, 3. Let's see what C1 and C2 have to be. So this is 3, 2, 4, 3, negative 4, 8. Subtract row 2 from row 1. We'll get 1, 1, negative 12. 2, 3, 8. Now I'm going to multiply row 1 by negative 2 and add it to row 2. I'll get 1, 1, 0, 1. So we're multiplying by negative 2, so this will be 24. So 32 and negative 12. And then I just want to subtract row 2 from row 1. I'll get 1, 0, 0, 1. Negative 44, 32. It's really big numbers, but let's see if it works. So I'm going to put a negative 44 here and a 32 here. Okay, let's get out a calculator. So 44 times 3 is 132. So let's put on this side what we're getting. This is 132, but a negative because I have a negative there. Plus, then 32 times 4 is 128. 128. Add those two together, so 128 minus 132 is negative 4. We got this one. And now let's just check the other one. So 44 times 2, here we have a negative 88 plus 96, and that should be 8, which is correct. So even though these were really big and I almost thought maybe that wasn't correct, looks like it is correct. So now we've found V in terms of B2. So this coefficient matrix is negative 44, 32. So we didn't do anything wrong. This is definitely correct. But now I want to use what we found in the last video, those change of basis matrices, to show that this is actually the case. So let's go with this one. we have that V of B1 is equal to 2, 6. And we have this change of basis matrix that takes B1 to B2. We know that this matrix, let's go scroll back up. So B1 to B2 is this one. -1, -7, 1, 5. So let's put this down here. -1, -7, 1, 5. And I'm going to show you that if we take this matrix I, B2, B1, and multiply it with this matrix, we should get V, B2. Let's see if that's the case. So we're going to take -1, -7, 1, 5, multiply it with 2, 6. What do we get? We get -2 minus 7 times 6, I think that's 42. And then we get 2 plus 5 times 6, that's 30. So we get -44, 32. Let's look back at what we had, -44, 32. So what I want to say now is, remember how we found this matrix? We actually found the C1 and the C2 in front of those vectors by making an augmented matrix. Well, this time, instead of actually doing that, once you have this vector here, all you have to do is you just take this matrix that you found by the change of basis matrix, all that stuff you did, and just multiply it with this, and you'll get this matrix. You don't actually have to worry about the C1 and C2. Now you just get it by using the change of basis matrix. And let's verify that I, B1, B2 times V, B2 is equal to V, B1. Remember, these cross out and give us what we want, just like this one. Okay, so this matrix, B1, B2, B1, B2 is right here, so I'm going to copy this one. Let's put it right here and multiply it with our large matrix, wasn't the large number matrix, -44, 32. If we have the right change of basis matrix, this product should give us this 2, 6. So let's see. This is equal to 5 over 2 times -44 plus 7 over 2 times 32. And on the bottom we have -1/2 times a -44 minus 1/2, 32. Okay. This is -22, so that's, I think that's -110. Okay, and then plus, here we have 16. I'm going to need a calculator for that piece. So 16 times 7 is 112. And this is going to be 22, negative and negative make a positive, and then a minus 16. So it looks like we get 2, 6. Exactly what we wanted. So again, if I gave you one of the vectors, I tell you what the coefficient matrix is in terms of B2, and I ask you what the coefficient matrix is in terms of B1. This one's already given to you, and if you know the change of basis formula, you just need to multiply these two together and you'll get that coefficient matrix. You don't actually have to write out what C1 and C2 in front of those vectors like we did earlier.